Okay, we're looking at 15.3, classify plane figures, and we're going to learn how you can use the strategy of draw a diagram to classify plane figures. And our diagram here is what's called a Venn diagram. Now today's lesson is going to be a little bit more guided with you as opposed to the other ones where we're solving mathematical equations. This one is going to deal with more of the logic aspects of the plane figures, of polygons, quadrilaterals, and all the shapes that we reviewed earlier in the previous sections. So if you have your notes, please have them handy so that you can refer back to them. This is a special lesson where we're going to have mostly a discussion of the characteristics of the plane figures that we're going to be talking about. So let's go ahead and get started. So we're looking at a Venn diagram, and what a Venn diagram does, it shows how sets of things are related. So in the Venn diagram at the right, this one circle has figures that are rectangles. Okay, and this is the Venn diagram that we have. One circle has figures that are rectangle, and figures that are rhombuses are in the other circle. So rectangles, rhombuses. Then the figures in the section where the circles overlap are both rectangles and both rhombuses. So that's what the Venn diagram does. Okay, it compares two different things, and it tells you which the ones in the middle have characteristics from both circles. The ones outside have only characteristics of the title that's on top of that circle. So we're going to ask the question, what type of quadrilateral is in both circles? Okay, so we're looking at these right here, and we're going to walk through it. So a lot of this lesson today, it's logic, but you need to know the characteristics of your plane figures, of your shapes. You need to know that. So what do I need to find? Well, you need to find what type of quadrilateral is in both circles. So this is your sentence that goes here. What type of that's what you're trying to find. What information am I given? What are you given here? Or you're given the circles are labeled as rectangles, and the circles are labeled as rhombus. So you will put rectangles here and rhombus here. What is my plan or strategy to find this answer? What type of quadrilateral is in both circles? Well, what I'm going to do is I'm going to identify its lines and if it has right angles. Okay, I'm going to identify the lines and if it has right angles. Okay, and we'll answer this question last. Now I have something already for you here. Again, I will describe the figures in the section where the circles overlap by their sides and angles so I can name the figures. So that's what I'm going to be doing to solve. That's what I'm going to do. I'm going to identify those by its sides and angles. So I went ahead and have this handy for you here, but I wanted to walk you through it. Okay. So what is true about all quadrilaterals? What is true about all quadrilaterals? They all have 4 sides and 4 angles. All quadrilaterals have 4 sides and 4 angles. Which quadrilateral has 2 pairs of opposite sides that are parallel? Which quadrilateral has 2 pairs of opposite sides that are parallel? Well, that would be a parallelogram, a rectangle, a square, and a rhombus. A parallelogram, a rectangle, a rhombus, and a square. Which quadrilateral has 4 sides of equal length? 4 sides of equal length. Well, that would be a square, and that would be a rhombus. A square, and a rhombus, 4 sides of equal length. Which quadrilateral has 4 right angles? Well, it is a square or a rectangle has right angles. A square or a rectangle. Squares and rectangles have 4 right angles. The quadrilateral in the section where these circles overlap, which are these right here, they have 2 pairs of opposite sides that are parallel, 4 sides of equal length, and 4 right angles. So squares are in both circles. So they have, I'm trying to make this smaller so I can read it. And so they have how many sides? 2 pairs of opposite sides that are parallel, 4 sides of equal length, 4 sides of equal length. They both have 4 sides of equal length, and 4 right angles. So that's how he's identified these right here. So squares are in both circles. Now the question here asks, does a trapezoid fit in the Venn diagram? The trapezoid does not, because the trapezoid only has 1 pair of parallel lines. Okay, 1 pair of parallel lines, and it has no right angles. So it will not be able to fit in this Venn diagram. It does not work in here. Okay, now we're looking at the next one here. We're looking at the Venn diagram at the right here. Shows the figures Abby used to make a picture. Where would the figure shown below be placed in the Venn diagram? This one, where would they place this one? Will it be in the quadrilaterals that has 4 sides, or polygons with right angles? Polygons, remember a polygon is a plane figure made out of line segments. A polygon is a plane figure made out of line segments. So this one, so what do you need to find? You need to find where this figure shown below be placed in the Venn diagram. What information are you given? Well, you're given 1 circle of quadrilaterals, and you're given 1 circle of polygons with right angles. What is your plan of strategy? What is your strategy? Well, you're going to identify the figures in the circles that overlap, okay, and see and compare them. And I have that already here for you, so you can refer back to it, so I don't have to write it out. What information is given? We already talked about the labeling of the shapes. What's your plan? I will use what I know about 2-dimensional figures to find where the figure should be placed. I'm going to use what I know about 2-dimensional figures to find out where this goes. So how do I solve it? What is true about all quadrilaterals? So I got to look at quadrilaterals. They all have 4 sides, and they all have 4 angles. Notice how this one doesn't. They all don't have 4 sides or 4 angles. What is true about all polygons? Okay. What is true about all polygons? Well, true about all these polygons, they are closed figures made up of line segments. Okay. Closed figures made up of line segments. Now, how can I describe the figures in the section where the circles overlap? Well, they all are quadrilaterals. That means they have 4 sides. And they all have a right angle. Okay, it doesn't say 4 right angles. They have a right angles. Does the figure here have a right angle? Yes. Yes, it does. So this figure would go here in the middle. Okay, and if you turn this one, flip it over, it's the same shape as this one here. It's just moved a little bit different. So that's how we solve this one. We walk through what is true about quadrilaterals. You identify that. What is true about polygons? You identify that. Then you look at the ones in the middle, okay, and then see if that figure has either these characteristics, the quadrilaterals, or the ones with the polygons with right angles. How many figures do not have right angles? How many figures do not have right angles? Well, this 1, 2, 3. 3 figures do not have right angles. All of these here have a right angle. This one has 2 right here. This one has 1, and this one has 2. These quadrilaterals do not have right angles. So we label them. So we label these as quadrilaterals and polygons with right angles. How many red figures have right angles but are not quadrilaterals? How many red figures have right angles but not quadrilaterals? So they're not in here. They can't be in the middle. So it would be which one? This one, the triangle. It's the only it's not a quadrilateral, but it does have a right angle. The right angle is right here. So what is the difference? What is a different way to sort these figures? I could also sort them through polygons with parallel sides and polygons with right angles. I could have also polygons with parallel lines here and polygons with right angles. Instead of using quadrilaterals, I could have just said polygons with parallel lines. This one has 2 parallel lines. This one has 2 pairs of parallel lines. And polygons with right angles. Notice these do not have lines that are parallel to one another. Okay. Okay, so let's move on to your next question. Get this one. Okay, now we have the share and show, where we have these figures here, and we're going to put them into these circles. So Jordan is sorting the figures on the right in the Venn diagram. Where does the rhombus go? Well, first look at the sides and angles of the polygons, alright? So we're going to put all the polygons that have right angles here. Okay, polygons with all equal sides and length here. Now the polygons with all equal sides and length here cannot have right angles. The polygons with angles here cannot have all sides of equal length. So next, draw the polygons in the Venn diagram below. Okay, let's wait on this a bit. Let's look at this symbol here. The finger has how many sides of equal length? It has 4. How many right angles? 0. It has no right angles. So it does not have 4 right. It does not have any angles, any right angles. So where would it go here? Well, this is polygons with right angles. This is also polygons with right angles, but also polygons with all sides of equal length. But since this one does not have a right angle, this rhombus would go here. And your circle would look like this. Okay? So you'd put these are all the polygons with right angles. These are all the polygons with all sides of equal length. And these, the square and the rhombus, are both have polygons with right angles, and they also have all sides of equal length. Okay? Where in the Venn diagram would you place the trapezoid? Well, it can only go in the circle where the polygons with right angles, because the trapezoid does not have all sides of equal length. You see that? Does not. Okay? So you see what we're doing? We're looking at the characteristics of each one and just walking through it. It can be a little bit overwhelming if you don't know what a quadrilateral is, what a polygon is, what a rhombus is, or the characteristics. That's why you need your notes. The only way you're going to learn this is to review those notes and learn them. And this is practice. And if you have any questions, please ask me. I'll be more than happy to address it again. Okay, we're looking at this one. Emma drew the Venn diagram at the right. What labels could she have used for the diagrams? Where would each label go? So first one, on this circle, they're all what? Well, they all have how many sides? 1, 2, they all have 4 sides, but they don't have any right angles. So I could use quadrilaterals with parallel sides. Okay? This one I could use and say, well, these are all polygons with a right angle. These are polygons with right angles. So I could do that. And then the shapes in the between are both quadrilaterals with parallel sides. And they're also polygons with right angles. So we're just looking at the characteristics of each. And then putting our label here. But our label that we have here, none of these shapes can have these characteristics. Okay? So then you have to know, look at the words. Polygon, quadrilateral, parallel sides, right? That's the verbiage that you need to understand. Now the next one, we're going to see several different examples. But how would you label these in a Venn diagram? You got a parallelogram, a rectangle, a square, a trapezoid, and a rhombus. Well, you can label them as polygons with parallel lines. That's one way, right? Or polygons with no right angles, or polygons or quadrilaterals with all sides the same length, or quadrilaterals with right angles. So there's a vast way to create these Venn diagrams. But so long as you create them and you name them, and if you think of the example that we had earlier, this one, you can label them. This would be a possible way to do the last one. You can label it as quadrilaterals and polygons with right angles. You can label these as polygons and quadrilaterals and polygons with right angles, and you'd be able to make the Venn diagram as so. So have fun with this, and again, practice. The Go Math video also does a very good job taking you step by step, and it gives you more pictures and walks you through it. So the Math on the Go video that you have, please refer to it. That's another resource. Please, for this lesson, I would suggest you go back and look at the 15.3 Math on the Go video, which is this one here. Oh, I'm sorry, it's on the it's this one, Math on the Spot video, and I walk you through it on RenWeb. It shows you exactly where to go, and if you go, I'll show you exactly where you need to go. Oops, oh, I closed it. No, did I close it? I'll show you where you find it. Okay, let me go and show you. You go to your Think Central site. I'll have to log in again. But you go to your Think Central site, to your account, and Math on the Go videos. Your dashboard's going to look different than mine, but you do have this one, Math on the Spot videos. So you go there, and all of this is on RenWeb because it gives you the spots. Gives you the steps to do this. Okay, it's so whatever, Unit 4 and Unit 5, Unit 18. Okay. Sorry. That's Group D. I'm sorry. So we're doing 14. Okay. Unit 4, Module 15, and then 15.3. Okay. And that has a real good video, and it takes you step by step also, and it's a more in-depth explanation. So please refer to this video and review this one before you do your 15.3 or afterwards, or if you have to go and follow up again, I would highly recommend you go back and you review this video. So again, you go to your Go Math, you go to the Math on the Spot videos, and from there you go to Unit 4, module 15, and then you find 15.3, and then it has the video. And notice it's a real good explanation of how things work, and it walks you through it a little bit slower. And some of you may just need a different voice than my voice, okay? So sometimes it's a different experience. So if you have any questions, again, please ask, send me an email, and I'll get back to you as soon as possible. This is Mr. Lopez signing off.